The as machine finished is the surface condition of a part immediately after it has been machined using tools like lathes and milling machines. It is the result of the machining process, so usually the texture is rough and there are visible tool marks. Here are some situations where an as machine finish might be appropriate. When developing prototypes, depending on the application, using an as machine finished is sufficient for initial testing and validation, saving the need for a more polished finish until later stages. You can also consider 3D printing for prototyping. For parts that will be hidden from view or play a purely structural role, such as load-bearing mechanical components, an as machine finish could be suitable. When parts require bonding with adhesives or coatings, a slightly rough surface enhances adhesion properly, ensuring a robust bond. When planning to paint or coat a part with powder, using an as machine finished for the base material can effectively promote adhesion, potentially reducing the necessity for additional surface preparation. As machine finishes are less expensive compared to more polished or cosmetic finishes. This is one of the main reasons engineers choose an as machine finish. Here are some situations where you should avoid using an as machine finish. In applications where the part's appearance is vital, like on consumer products or decorative items, an as machine finished might appear rough and unappealing. For applications needing low friction or tight tolerances, it's often beneficial to consider additional surface treatments or finishes. This helps minimize friction, improve durability, and enhance overall performance. In industries like food processing or pharmaceutical manufacturing, where hygiene and cleanliness are critical, it's essential to have smooth, easily cleaned surfaces to prevent contamination, as machine finishes can trap particles and make sanitization challenging. Components used in optical instruments, cameras, sensors, or screens often require exceptionally smooth surfaces. This is essential to reduce light scattering, prevent interference, and ensure precise measurements. Gaskets are used in many applications, and the parts involved must have a very low roughness on the surfaces in contact with the seals, not to damage the rubber. In aerospace and automotive fields, vital components like engine parts and aircraft gear require exceptionally precise and smooth finishes to adhere to performance and safety standards. Smooth and biocompatible surfaces are often essential for medical devices to ensure patient safety and comfort. Components meant to rotate or slide, such as bearings, shafts, and gears, benefit from polished surfaces. This reduces friction and wear, ultimately expanding their operational lifespan. Components utilized in applications involving fluids, such as pumps, valves, and nozzles, frequently demand precise finishes to optimize fluid dynamics and minimize energy losses. Hope you enjoyed this video and found it interesting. Please contact us if you have any questions. Until next time, stay curious.